All right, find the derivative of this function. It's a rational function. All right, and we are going to use the chain rule. Okay, so let's go through and do that. So this is f prime of x. So the chain rule, this is what we're gonna do. First, we're gonna deal with the entire thing as a power rule. Okay, so 9 comes to the front, and we get x minus 2 over 2x plus 1, and then the exponent becomes 8. And then I'm going to use the Leibniz notation. This becomes d dx. That means now we have to multiply that, the first term, by the derivative of the inside of that bracket. Okay, I'm just going to put it as d dx of x minus 2 over 2x plus 1, and then we're going to rewrite it again. Okay, so the first term stays the same, so we have done the derivative of the first to the power of 8, and now this is the quotient rule that we're going to use, and the quotient rule we're going to use, and that's multiplied by. So now we're going to go through and use the quotient rule, and that is basically the derivative of the top. So derivative of x minus 1, that's 1 times 2x plus 1 minus, and then you leave the top alone, and then derivative of the bottom times 2. Okay, and all of that divided by 2x plus 1 squared. All right, the third line, which is right here, when I have decided to change the exponent here for the 8, so I just use the exponent law, and I just separated the numerator and denominator and just wrote it in a form that is separated, because it's easier that way. And you can see, because there's a 2x plus 1 in here, 2x plus 1 in here, so we can actually use the exponent laws to add the exponents. And in here, what I have done is basically went ahead and multiplied and then simplified, and I have to simplify. I haven't simplified yet, and then let's do that. And here we can see that 2x minus 2x, that's 0. 1 plus 4 is 5. So the final answer, 1 plus 4 is 5. So it would be 5 times 9, that's 45. And that is x minus 2 to the 8 all over, and that would be 2x plus 1 to the power of, to the exponent of 10. Excellent. And that is our final answer.